All right, 2.2, and it says show that 12 is the limit of this by using sort of the definition, which means that if this is really the limit of this, then the difference between this and this will approach 0. So we're going to look at, and this is in terms of absolute value. So I just take the limit of what it says it is, 12, minus what we're trying to find the limit of, and look at what happens to this as x gets closer and closer to 4. Well, if I put in 4.1, then this is going to be just a little away from 0, and if I put in 3.99, it's going to be a little bit away, but if I could put in 4 exactly, it's going to be 12 minus 12, which is 0, and I can get anything, I can keep getting closer and closer to 0 by putting numbers closer and closer to 4 without actually putting 4 in here. The whole point of this is, what if I couldn't put 4 in there? What if this was undefined at 4? Is the difference getting closer to 0 as we get really close to 4? And so what you can kind of do is go to your calculator and put in the absolute value, which is a math number, and put in 12 minus 3x and close parenthesis, and then we can use what we've been doing in this 2.2 section, which is we set the table set to ask and then go to the table, and we put numbers really close to 4 without putting 4 in, like 3.9, 3.99, 3.999, and as we do that, this goes from 0.3 to 0.03 to 0.0003, and as we keep getting closer and closer to 4, this keeps getting closer and closer to 0. We can also come in from the other side. We were coming in from the left side there, the smaller side of 4. Now we can go from the bigger side of 4, 4.1, which is 0.3, 4.001, which is 0.003, 4.0001, which is 0.0003, and I could just keep getting closer and closer to 4 without getting it, and we can see that it's getting closer and closer to 0. So that must truly be the limit. We can get arbitrarily close to 0 by just keep getting closer and closer to 4. Same idea for this one. So what I would put into my calculator would be 5 minus, and it doesn't matter which way I subtract these because it's absolute value, so I'm going to write it the other way, 4x squared plus 2x plus 5 minus 5, and we're supposed to get close to 0. We're going to let x go to 0 and try to show that this difference goes to 0. Well, these two cancel, and clearly 4x squared plus 2x, it's a parabola, and when you do put in 0, it's 0, and as you get close to it, it's going to get really close to 0. And I could do it on the calculator, but that's what we're supposed to argue, that I can make this parabola get arbitrarily close to 0 as we get really close to 0 with the x. And that's without putting 0 in. Okay. And the reason we're doing that is for ones like this, where we can't put 0 in. This is division by 0, and they want us to see what this approaches as x gets, or in this case theta, but we're going to put in x, gets really close to 0. Now we've already done something with this in 2.5, and we know what this one is. It comes out to be 0, but let's see how it looks. So we're going to type in the equation, clear, and we're going to put in parenthesis for the numerator, cosine x, close parentheses for the cosine x, minus 1, close the numerator, divided by x, and then we'll just go to the table and get really close to 0. So 0.001. Well, that's already really tiny, negative, but tiny. 0.1 is pretty small, negative 0.05. 0.01 is negative 0.005, and 0.00001 is really small, 0.00000 negative. 5 negative. I keep going further, even smaller, closer to 0.0000001. It rounds it off to 0. And I can also come from the negative side, negative 0.1. And it's about 0.05. Negative 0.0001. And that's really small, negative 0.00001. It'll say, oh, that's, as far as I can tell, it looks like 0. That's what the calculator is saying. So this one is 0. Supposed to do the same idea for this one. But we're supposed to come in only from the negative side of 1. Not to negative 1, but from the negative side of 1. So I'm going to delete all these. Put the equation in, which is clear, parenthesis 3 minus x, close parenthesis, divided by, parenthesis x minus 1, close parenthesis. And second table, we're going to go closer to 1 from the lower side, not negative numbers, but come at negative from the lower side. So we're going to use 1, so it'll be 0.9 is getting close to 1 on the lower side. And that's negative 21. Let's put 0.99, that's getting closer. And that's negative 201, get closer. 0.9999, and that's negative 20,001. And if I keep getting closer, 0.999999, it says negative 2 times 10 to the negative 10 to the 7th, which is negative 20 million. Where does this seem like it's headed? Well, it looks like it's headed to negative infinity. Okay? That's the idea. Now, if think about this rational function, it has a vertical asymptote at 1. And as we get closer to it from the negative side, this is taking off to negative infinity. The other side would go to positive infinity if I put that in there. So that's what the idea was for 2.2.